Okay, this question just asked, figure 6.1 shows two equal but opposite forces acting on an object. It gives us two forces and it gives us the separation between the forces. Now it says the separation between the two parallel forces is 3 centimetres. Determine the torque of the couple exerted on the object. Notice the units it gives you here is Newton meters. So we've got the units in newtons for the forces, but the distance is in centimetres. So, to calculate the torque of a couple, you only need the value of one force multiplied by the distance between the forces, which, because it's 3 centimetres, will be 0.03 metres. And that will give us 0.12 Newton meters. The next question says to calculate the total moment of the forces about the point O and state the significance of the value. Now, we do not have the exact distance here, it's just given us x. So what we can do is we can calculate the moment by using simple equations. So for our first anti-clockwise force of 4 newtons, this one here, then we're first going to know that the distance is x. So the moment of this force is 4x. So 4 times x is anti-clockwise. The other force is 4 newtons, and the moment is actually, the distance from the pivot is going to be x plus 0.03, and that equals clockwise moment. Now, to calculate the total moment, we simply take one away from the other. So if we expand the brackets, in this case, in the second case, we're going to get, so anti-clockwise is 4x minus 4x minus 4 times 0.03. And that will give us an answer. 4x minus 4x is 0, so we're going to get minus 0.12. But effectively, the moment is the same. So, how do we explain that? And the fact is, moments are the same with any point as the pivot. That is, it does not matter where you take the moment from, you will still get the same overall moment. Next one, 2 conditions necessary for an object to be in equilibrium. Simple, resultant force 0, and overall moment equals 0. You might also say sum of clockwise moments and sum of anti-clockwise are equal. Now for the next part, we want to calculate the density. The density is mass divided by volume. We've got volume given in meters, we have kilograms, the density is kilogram meters per to the minus 3. So this should be absolutely fine. It's going to be 45 divided by 0.6 times 0.6 times 0.05, and that will give us the density of the concrete. And the density equals 2,500 kilogram per meters cubed. The next one shows this concrete paving slab in equilibrium. Now it's given us we know the mass from the first question here, and it's given us a force here of W as well. Now we need to know what W is. We know it's going to be equal to mg. So we know that the mass is 45 and g is 9.81. So might as well do that now. We're probably going to need it in this question. Let's have a look. 2 forces acting on the slab are slow. The weight of the slab is W. The force F is applied at right angles to the end of the slab. So that's important, that this is a right angle here where F is applied. By taking moments about P, determine the size of the force F. So again, we need to total up our anti-clockwise and our clockwise moments. So anti-clockwise, we have the force F, which is being applied to lift the slab effectively. So we want to know what F is. We know it's going to be F times 0.6, because the perpendicular distance here is 0.6 metres. Now it tells us that the concrete paving slab is in equilibrium, so that means that the two moments must be equal. So if we know the anti-clockwise moment is force times 0.6, and we know that the clockwise moment is equal to the perpendicular distance from the pivot, so here we are, 0.15 times 45 times 9.81, which is the force. We know that these are equal. So if we want to calculate F, it is equal to 0.15 times 45 times 9.81, sorry, divided by 0.6. And this should give us the force. Now it's given us 110.3625. I'm going to just shorten it to 110 newtons for two significant figures. And that's it. That's 12 marks.